Actually, we were discussing about VLAN, what is VLAN, why we create a VLAN, what is the advantages of VLAN, and then we create a VLAN, we delete a VLAN, we modify the VLAN, then we saw that where standard VLAN are stored, we also saw the data VLAN, we also check voice VLAN and the combination of both VLAN. Then we create a VLAN more than one switches and see that if you want to create a VLAN more than one switch, then you need a trunk port which is between two switches or more than switches as much you have switches. But we saw that one VLAN cannot communicate to another VLAN. But we want in the future, maybe we want that one VLAN can communicate to the other VLAN. We need all the advantages which we discussed there, like a separate domain, like a separate management, like a separate separation, logical division, everything, which we saw that we have these advantages of VLAN. But we want to keep all the advantages, but just we want communication between VLAN. So how is it possible? Maybe in the future teacher can access student result. Either student want to access teacher some assignment. Either HR want to access IT. Either IT want to access HR form which is for the vacation form or something. Because the VLAN we created, one VLAN cannot do communicate to the other VLAN. But we want this. So as a layer 2 switch is not possible because they are totally separate as a layer 2 switch. So if we want such things, we have two type of method. One of them is called inter-VLAN routing, which is router on stick method, and the other is SVI. So we will see both the method. First we will see router on stick method, which is old method, and still many countries are using this one. I always give example when I was in Pakistan. So in that time, this method was the best method because we have limited resources. So in university, we deploy this method. When I visit many universities to deploy which method is the best one, so every university in Pakistan, most of them university was using this method. But when I came here, so I saw that because here is more resources, so they are using layer 3 switch. We will discuss. SVI, we call them SVI as well. So instead of using router and layer 2 switch, we have layer 3 switch to replace these two devices. Rather than using two devices, why not one devices? But their device is expensive. But nowadays you will find everywhere. But we will discuss both method. Router unstack method. As I told you, we have created VLAN. So when you created VLAN, one inside VLAN you can do communication. No doubt it will be successful. It's successful. But when you send a packet from one VLAN to another, it will not go. It will fail, and it has to fail because they are in separate VLAN. We check this. But we want communication between inter VLAN. So router unstick method means router unstick. We need a layer 3 device to communicate different VLAN because these like a different subnet. These like a different network. So definitely we have a device which can do this job for you, and that is a router. But now the issue is I have two VLAN. So I need two cable to plug to the router. One cable I will put here in VLAN 10 and the other VLAN 20. Suppose I have VLAN 10 and 20. But what about tomorrow I have another VLAN 30. Then I will need a third cable, and maybe in the future I have another 5 VLAN. Then it's not possible because in router maximum you can see 4 port. It's not a switch that you will see many port. So it means there is an issue. So what is the solution? Because I cannot plug many cable there. So the solution is I can use one cable, but I will create sub interfaces. It means this cable will work for different VLAN. This cable will logically work for VLAN 10, VLAN 20, 30, 40 and so on as much you want. You can create million sub interfaces. It's not an issue. So this is the solution. Yeah, it will come in your mind that why? Because this is single point of failure. All the thing and the whole burden and everything is in this cable. This is only 2 VLAN. Maybe these are 200 VLAN. Everyone will send the data and receive the data in one single cable. So it's a big issue. Single point of failure. If this cable is broken, everything is down. Intercommunication will be not possible. And also if this device is fail, everything will be fail. And this cable will be overloaded. We know this. These are the disadvantages. That's why. But this is a method to use them in old days. Maybe you will find them in many places nowadays as well. So now let's do it. How it work? Label. Let me go to switch first, and I will need two VLAN, two separate VLAN, and the first three port in one VLAN and the other in the other VLAN. So let me go to, maybe I created already, so it's not created. No issue. We know how to create it. First VLAN 10 and name them students. VLAN 20 and name them teacher. Two VLAN are created. Now put them range 0/1-3. Switch port access VLAN 10. The first three port are in student and interface range 0/4 I believe 6. Yeah, up to 6. Switch port access VLAN 20. No shutdown. Let's check them. Show VLAN brief. So now we divided the first three port in 10 VLAN students and the other in teacher. You can create any VLAN. This is just an example. Now we know these will not communicate. It's for sure. Yeah, we know this. Now how to possible communication. Let me ping from here. It will not ping. We know this. IP config. My IP is 1.2 and I am going to ping 192.168.2.2, which is impossible as a layer 3. Even my subnet is different. This is 192.168.1 and this is 192.168.2. Leave it VLAN aside. Even my subnet is different. So it's not possible. It will not do communication. No doubt. It requests timeout, requests timeout. Let me put them and continue. It will not work. I'm going from a different subnet to different 192.168.1.2 to 2.2, which is not possible. Let them possible. First, let me go to switch which interface is connected to the router, which is 0/7. And 0/7 interface is here in VLAN 1. I don't need them here. Interface fast Ethernet 0/7 switch port mode trunk. As we know, we need a trunk port to work for all VLAN. This is the first step in switch. It's okay, the switch part is done. Now everything is coming to router. So let me click on router and the interface is 0/0. Okay, no issue. And let me go to router configuration interface fast Ethernet 0/0 and make them no shutdown. By default router interfaces are down and by default switches interfaces are up. So now is up. I don't need anything more. I just need this interface to be up. If I check them, show running, you will see this interface 0/0 is up. That's it. Now in my case, I have two VLAN. I need two sub interfaces. If it is 500 VLAN, you need a 500 sub interfaces. Let's do it. How it work? Go to configuration, interface fast ethernet 0/0 and put dot here. And when you put question, look it, I can create million sub interfaces. And let me type 10. It doesn't mean that this is for VLAN 10, that's why I put 10. You can put anything. But just for troubleshooting purpose, it's better to give the VLAN number here. It's not necessary to be similar with the VLAN number. So now I am in the sub interface mode. Okay, now assign the IP address. No, before I assign the IP, make encapsulation .1q, which we studied .1q. It's a trunking protocol to tag. Here is important to put the correct VLAN number. And I'm creating this sub interface for VLAN 10. This is important. Doesn't mean this one. It has to be any number, but this has to be matched with VLAN number. Now assign the IP address 192.168.1.1, 255.255.255.0 and no shutdown. So one sub interface created for this side. I need another sub interface. Go to router again and up arrow, up arrow, up arrow and just make this 20. Another sub interface. I will show you now if you have a doubt. And make encapsulation .1q and make them 20 and put the IP 2.1 because they have different subnet. That's it. Let me show you. Show running. Now you will understand what I done. Look it. This interface I divided in two parts 0/0 10 and 20. So it's assigned 1.1 and this is 2.1. This is for VLAN 10 tagging and this is for VLAN 20 tagging. That's it. This is what I want. In the future, if you have VLAN 30, just .30 and encapsulation .1q30. 40, 50, 60 and so on. Copy paste and change the number. Now if I go to PC1, before it was not doing communication. Now it started from here is doing communication. Look at request timeout and this started now. Let me do it again. Up arrow now is doing communication 2.2 from if you want to need in simulation mode. So let me show you in the simulation mode as well. Let me send a packet from here to here. It will go to the router because it's not a switch job. And it will return on the same interface and it will go to the other way. Sorry. And from here it will go to the router again. It go to the router up and again it will come on the same interface. And this way it's successful. It means everything is going and coming on this interface. That's why I told you single point of failure and also the traffic is coming and going, more burden on one interface. But this is what we can do. It's called router unstick method to allow communication between inter-VLAN. Let's go to the second part, which you will see normally everywhere. Nowadays, everywhere by the way. How? Let me open this topology. Rather than to use two devices, why not just delete router, just delete layer 2 switch and just buy one device, multi-layer switch, either layer 3 switch. Let me take a cable, connect That's it. I remove layer 2 switch and I remove the router. And I buy one device which is layer 3 or multi-layer switch. Let's do the same things here. Go to command line interface, which we done there. Configuration, VLAN 10, name student. VLAN 20, name teachers. Interface range 0/1-3, switch port access VLAN 10. Exit interface range 0/4-6, switch port access VLAN 20. Show VLAN brief. 3 interfaces. Again it will not work. No doubt it will not work. Even there everything is different. But anyhow, let me try from here to here. It will not go. It will fail. Because layer 3 switch is also work like a layer 2 by default. It's not like this that it will start work automatically. So what I need? First, the two VLAN which I created, 10 and 20. Show interface, show IP interface brief. But it's not showing here. No, VLAN 1 will show here until you assign the IP. Let me go to the first interface which I created, VLAN 10, and assign IP 192.168.1.1, the one which assign I to the router. No shutdown. Now go to VLAN 20 and assign IP to range 1, which I done in the last part of in the router, and no shutdown. Now check them. Show IP interface brief. Here you will see is up and now this range. But still communication will not work, no doubt. Let me make them real and quickly send the packet. It will not go, it fail. Even if I do it again, it will fail. Fail. So SVI is not the only solution. Even I have SVI now. Show IP route. There is no such route. By default, layer 3 switch is also working as like a layer 2. You need to type this command to make them layer 3. What is the command? IP routing. Now there will be route automatically. Show IP route. Yes. Now it will work. Ping from here to here. It failed first time, but second time it will work. It's successful. Again from here to here, it's successful. If you want to see in simulation from here to here, because this switch is like a layer 3 now, it can do intercommunication as well and create a VLAN as well and everything for you. So that was the second method and the preferred method, which we call them switch virtual interface. Means a layer 3 switch. We use this method, router method. We make a two different interfaces and we sub interfaces to make one interface divided in two, and it can be divided in 3, it can be divided in 20, as much you want. We divide them and we make a, this was called router unstick method. Then we use this method, which is the prefer method, layer 3 switch. Okay, so that's done. Now coming to another topic. We use this topology. I created VLAN here, then I created VLAN here, then I created VLAN here. Now the question are coming in mind, Is there any way these are only 3 switches? Maybe these are 300 switches. So in every 300 switches, I need to create VLAN 10, VLAN 10, VLAN 10, and then VLAN 20, VLAN 30, VLAN 40, and so on. It's a difficult task to create in 300 switches again and again the same things. I know we can do copy and paste as well, but again it's a difficult task. Is there any way that I create a VLAN in one switch and it's create automatically in all switches, 300 switches or 500 switches? So yes, it's called VTP, VLAN Trunking Protocol. A protocol which create VLAN in one switch can distribute to the entire domain. But this is Cisco proprietary, only run on Cisco devices. VTP, VLAN Trunking Protocol. VTP has 3 versions, version 1, 2 and 3. 3 we discuss in CCNP and 1 and 2 is almost similar. Nothing much different, almost same. VTP has 3 modes which we will see. Server, client and transparent. By default, every switch is in server mode. By default, VTP domain is null. By default, version 1 is enabled. By default, VTP pruning is disabled. One switch can be part of one VTP domain at a time, only one. If you change the name, it will go to another domain. So it means one switch can take participation in one time in one VTP domain. VTP domain is nothing to join a group. So anything created, they will join. But how the other switches will know that there is some changes? How the other switches will know that somebody created VLAN? By revision number. I will show you all these things, don't worry whatever I say here. Revision is a number which you do anything. Either you create a VLAN, you delete a VLAN, you rename a VLAN. The revision number will become increase, will become high. Keep in mind. VTP version 1 and 2 cannot advertise extended VLAN, which we discussed yesterday. Extended VLAN cannot be advertised by VTP version 1 and 2. VTP using this MAC address to send and receive the frame, and the advertisement is after every 300 seconds. This was some introduction about VTP. If you see show VTP, let me show you. If I go to any switch, so let's see the default thing. Enable configuration, host name SW1, exit. Let me show you. Show VTP status. Look at, but it's showing 2. Basically this is 1 and packet tracer is show 2, but it is version 1. How I know? Let me change it. VTP version 1. It say VTP is already in version 1, but it's showing here 2. So don't worry, in real switch you will see 1. By default, show VTP status. By default, VTP version 1 is enabled. One thing's proof. Revision number is 0, which we will see. By default, when you configure nothing, it will be 0. And we know by default there are 5 VLAN. VLAN 1 and 4 other VLAN. And by default, every switch in VTP server mode. By default, VTP domain name is null. Nothing is here. And pruning is disabled. So we saw this default thing. We also discussed VTP version. We have 3 versions, VTP version 1 and 2. 1 and 2 is similar and 3 is totally different, which we discuss in CCNP. Totally different, many things you can do there. In version 1 and 2, they store VLAN configuration in VLAN.dat file, which we know from yesterday as well. Advertisement is 300 seconds. We will see this one as well. Every switch can participate in one VTP domain at a time. These are the three mode of VTP. If I go here, configuration VTP mode, these are three mode: client, server and transparent. In client mode VTP, in VTP client mode, we cannot create VLAN, we cannot delete VLAN, we cannot modify VLAN, we cannot store VLAN. Neither we can create, neither we can delete, neither we can modify, neither we can store VLAN in client mode. Yeah, but we can advertise the VLAN. Advertise mean, suppose this switch is client. If he create a VLAN, he will accept the VLAN as a client, but it will forward to the other switches called advertisement, and it has to do. So client can do these things only. And I told you they are not storing the VLAN permanently. They are storing only because it's a client and running. Now coming to server mode. And server mode, VTP server, which is the default mode. You can create a VLAN, you can delete a VLAN, you can modify the VLAN, you can store the VLAN, and also you can advertise the VLAN to forward them to your neighbor. Two things are clear which we will see in the lab, but I'm telling you. In transparent mode, I can do each and everything which server can do. I can advertise the VLAN to the other, means if somebody create a VLAN, I will give it to him. But in transparent mode, it's not accepting anyone VLAN. Neither it's give their own VLAN to other switches. Two things. Neither accepting someone VLAN, neither sharing their own VLAN to other. It means it's local. Local in the switch which is in transparent, they can create a VLAN, delete a VLAN, rename a VLAN, but not giving to anyone. That's why the config revision number will be always 0 of transparent, because revision number we are using that the other switch update themselves. We are using this method, but it's not accepting VLAN, so there's no need. So it will be always 0, which we will see. And I told you about the configuration revision number. It's a number which start from 0 and increase 65535, but not in transparent mode. And whenever you create, delete and rename VLAN, this number will increase. Keep in mind it will increase. Even you delete a VLAN, it will increase, so that the other can update themselves. Let's do the practice. But for VTP, we have few condition. It not work like this. Let me write the condition. The first condition is switch to switch link has to be trunk. First condition. Second condition is at least one switch in the entire domain or network has to be server mode. होई ना At least we need one switch to be server to create a VLAN. If we make all the switches client, so who gonna create the VLAN? So it's a common sense. The third one, if you put a password, VTP password, in case if you put, it has to be the same in all switches. Fourth, VTP domain name has to be the same. Definitely, if you fulfill this four requirement, then your VTP will work. So let's do it. The first condition, they say if you want to deploy VTP, switch to switch link has to be trunk, which we know, and why it's required. Because if you don't create a trunk, it will not work. Our VLAN will not go to the other switch, which we saw, and you remember that. So it's also logical. So let me go to first switch and make this port trunk. Interface 0/5 switch port mode trunk. And let me go to the last switch and make this port as a trunk. So I don't need the middle one. And if I ask you why we need the middle one, host name is 3. Interface 0/5 switch port mode trunk. I didn't make these two port trunk. Why? And the why answer you know, which we discuss. DTP. Due to dynamic trunking protocol, if you make one side trunk, the other will become trunk automatically. So I don't need to tell you this because we discussed this in last lecture. So first condition is done. Switch to switch link is done now. They say at least one switch has to be the server. In my case, all three are in server mode because by default it's a server mode. This is also done. If you want to put a password, it has to be the same and it has to be the same domain name. So let them give them domain name. How? Go to the first switch, VTP domain. In configuration mode, give them any name, suppose test. Done. Let's go to the second switch. Maybe it's took automatically. Sometimes it's took automatically as well. Control Shift 6. Host name is 2. That I know is a switch 2. VTP domain test. It's already test because through trunk is distribute them quickly. But the last one I need to change them. So let me come here. VTP domain test is done. Show VTP status. We have the same domain name. Test, test, test. This condition is done. I don't need to put the password. In case if you want to put the password, it has to be the same. So let's do it. In the first switch, VTP password 123. Then it has to be here the same. VTP password 123. And then it had to be here as well. VTP password 123. Done. Show VTP status. We have all the switches are in server mode. VTP domain are the same. VTP password are the same. Switch to switch string are the trunk. That's great now. Now I can use, if I create a VLAN here, it will go automatically to the other switch automatically. But let me show you one thing before we start. Show VTP status. What is the revision number? Keep in mind. This thing will tell to the other switch there something has happened. Maybe delete, maybe rename, whatever. So it's 0. Let me create a VLAN. VLAN 10. Exit. Now check, the revision number will become high. Look at this 1 now. Before it was 0. It will create this digest and will distribute to the other VTP advertisement. This switch will see, okay, something change. Show VTP status. Here has also become 1. And if I say show VLAN brief, there will be 10 automatically. Look at VLAN 10 is there automatically, and this 10 will be here as well. Show VLAN brief 10 is here as well. Because we all are server mode, let me create here VLAN. No issue. Shit. Control Shift 6. Configuration VLAN 20. I create a VLAN. Okay, let me give them a name as well. Name IT. How many changes I done? Keep in mind I done 2 changes. Show VTP status. So it will become 3 from 1 to 3 because I create a VLAN and I give them the name IT. So I do 2 changes. When I do 2 changes to it will increase 2 number. Now the other will know that there are 2 changes. So before it was 1, now it will be 3, and here will be, I will find VLAN 20. Look at VLAN 20 is here. And if I check show VTP status, revision is 3 now. And the same it will be here. Before it was 1. If I check again, it's 3 now revision. And if I check show VLAN brief, 20 is here automatically. All these 3 are in server mode. Anyone can create, anyone can delete. Okay, let me give you a delete option. Let me delete VLAN 10. No VLAN 10. I deleted the VLAN which was there before. It's not anymore. What will be the revision number? Keep in mind the revision will become high. It's 3 before, it will become 4. Sorry, show VTP status. It's 4 now. You have to keep in mind this thing. That revision will high even if you delete, even if you modify, whatever you do. So that the other switches can know. If I come here, it will say that something has changed. It's 4 now. And there will be no VLAN 10 anymore. Show VLAN brief. 10 is not anymore. And it was there before. And switch 2 as well. Okay, it's clear. This was in server mode. All the switches are in server mode. Let me make this middle switch client so that we can check the difference. VTP mode client. Now show VTP status. Look, it has become client now. The middle switch is client. Can he create a VLAN? No. VLAN 30. It's a no. Is not allowed when device and in client mode. It's a you are not allowed to create a VLAN because you are a client. You can just only accept the VLAN. Can I rename the VLAN? VLAN 20? No. Can I delete a VLAN? No VLAN 20. No. I can do nothing, only accepting the VLAN. And can forward the VLAN. Keep in mind, let me create a VLAN and switch 1. Because I am in the server mode, the first one. VLAN 30. I create VLAN 30. It will come automatically here. Do show VLAN brief. 30 is here. Now because I'm in client, do you think that it will forward 30 to this switch? Yes, this is the job of the client. Client can accept the VLAN and also it will forward to the neighbor that yeah, somebody created VLAN, take them. Let me check here. If 30 is here, then client can do this job for us. Show VLAN brief. Yes, 30 is here. So it's proof whichever I told you in the theory. that it cannot create, cannot change the VLAN, but it can advertise. Which they advertising? They give them to this device that somebody created 30. If he created a 40, he will pass to him this one, to this switch. This was in client mode. Now coming to the last mode, which is transparent. Let me make the middle switch transparent. Okay, you can switch anytime to any mode. It's not that you can go to only client mode and then you cannot change. No, you can. Right now show VTP status. I'm in client mode. Let me change them. VTP mode transparent. Now thing will change. What is the revision number? It will become 0. Look at it become 0 and it will be 0 because I'm in transparent mode. In transparent mode, revision number will always 0 because it's not giving detail to other. Let me create a VLAN. VLAN 40, VLAN 50, VLAN 60. I created 3 VLAN. Is it here? Yes. 30, 40, 50, 60. It will be here? No. Show VLAN brief. It's not here. 30, 40, 50, 60 is not here. 40, 50, 60. And neither it will be here. It's not here. Because transparent not giving their VLAN to someone else. It's only locally to this switch. Then you will say why we need. Sometime maybe in a company where one manager you don't want to distribute his VLAN detail to other switches to make that switch transparent. So his VLAN will be not distributed because you don't want this for security purpose perspective. Now create a VLAN here in the first switch. VLAN 80 suppose. Do you think it will accept? No, 80 will be not here. Keep in mind 80 is not here, only 60. But do you think it will give this 80 VLAN to this switch? Yes. Let me come here. Look at 80 is here. And third switch. He created a VLAN 80. He didn't accept, but he passed to him that take it. Somebody created VLAN 80. I can only help you to take this VLAN, but I am not taking anyone VLAN. I am king of myself. Neither I can give my VLAN to you, neither to him, because I'm in transparent mode. So we prove all these things. Now, if you want the simulation and to see the events, so let me remove and only put OSPF or BGP. Here is VTP. Where is this one? So let them check. After every 300 seconds, our buffer is full. So we have to wait. I just need to show you the VTP advertisement and the MAC address. Either I can show you from here quickly. Let me take two switches. Start and let me connect them together and let me on them these two switches. Go to switch 4 configuration VTP domain ABC, VTP domain ABC. Interface E0/0 switch port trunk encapsulation .1q switch port mode trunk. So it's trunk now, and let me see the advertisement. I can capture as well, and I can use the debug command because many commands are missing in packet tracer. So there will be, this is VTP packet. Let me capture one because they are all of them using VTP, CDP, DTP. They are using same MAC address. That's why all the protocol are here. Okay, but I need to show you the MAC address. So let me click on it and go to Ethernet, and this is the MAC address 01000CCCC. And this what I say that it using this MAC address 01000CCCC. So we test this one. Okay, let me show you the version 1 as well. Because I told you in packet tracer is showing version 2. Show VTP status. It's say version 1. So it's also proof. And we have 3 versions. So it's clear here as well. So by default version 1 is enabled. There are 3 versions which we can verify from here is better. And also we check the MAC address on which they are sending the packet. We capture the packet. What else to see? Yeah, after 300 seconds. I can on the debug command, either I can from Warshak can see that after every 300 seconds they will send the advertisement. And they are cannot advertise. VTP version 1 and 2 are not able to advertise extended VLAN. Is it true? Let me create a extended VLAN. When I create a VLAN here, VLAN 10, VLAN 20, VLAN 30, VLAN 40, because I'm in the same VTP domain, it will be here automatically, no doubt. Show VLAN brief. Look at 10, 20, 30, 40 is coming here. I created here. And switch 4 I created and switch 5 it automatically here. Let me create a extended VLAN. Extended VLAN start from 1006. Let me make VLAN 007. No, say VLAN 1007 is not here because I'm in VTP version 1 and 1 and 2 cannot advertise extended VLAN. So this one is also proof. Even it's cannot advertise private VLAN, but you don't know private, so leave it this one. And we know it revision number will become high. And we check this one, every switch is in server mode. There is no VTP domain. Version 1 is no enable, pruning is disabled. 3 mode server, client and transparent. We check these. We check the MAC address and all these things. And we check the 3 mode as well. VTP revision number, we check them. Pruning, you just need to know theoretically. Pruning means suppose you have VLAN 10 here, either VLAN 20. Suppose you have 2 VLAN 20 PC here, but it's not here, and switch 2 and switch 3. So if you send a packet, the packet will go because 20 and 30 is already created here, but no system is attached. It's like suppose you have 3 floor office. In the first floor you have IT person and HR person, but in the second floor is newly developed. So you have only HR person but no IT guy there. If someone came on the door and the lift is not working and he has to go on stair and he asks you, I need to go to the second floor for IT department, and you tell him don't go there, there is no IT department. We have a empty desk there for IT, but we didn't hire someone for IT yet. So the offices are there, but it's empty. So you don't need to go there. But he said, no, 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 I need to check them. And when he go there, there is no IT guy. He came back and told you, yeah, yeah, there is desk. It's written IT department, but no was there. So the same case is here. In switch 2 and switch 3, there is a VLAN created, but nothing is attached. So if you want to save the bandwidth of these interfaces, just enable VTP pruning. But VTP pruning can be enabled only in server mode because both are in server, so I need to enable N1. By default is disabled. Show VTP status. Look at pruning is disabled. And it's disabled, it will be disabled here as well. Show VTP status. It's disabled here as well. Let me on VTP pruning. VTP prune. It's enable. Look at it will be enabled here automatically. It's enabled here automatically. You just need to enable VTP pruning on one switch, the server mode, and it will automatically enable in all switches. Now every switch will care before sending a traffic, it will check that this VLAN exists there or not. If not, they will not send the traffic to save the bandwidth. That's it. This is the story. And we already know .1 key, which I told you yesterday. This is trunking protocol to take the VLAN so that the other switch can know easily. And I show you .1Q and ISL2 trunking protocol tagging VLAN. We also discussed about native VLAN yesterday. Yeah, the thing which I done here, this is automatic system. VTP pruning, this is automatically the switches will care about. There is a manual pruning as well, which is in your hand. Let me go here. Suppose show VLAN brief. I have 20, 30, 40 and 40 VLAN. Show interface trunk. Trunk can take the data for every VLAN. Do you think 1007 is there? No, because it's show interface trunk. It's only this VLAN. Even if it is there, but no one is attached to VLAN 40. So what you can do? You can do manual pruning. What to do? Go to the trunk interface E0/0 switch port trunk allowed VLAN and type here allowed only 1 10. Suppose only 1 and what is the other VLAN? Suppose 10. I told to this trunk interface which is between two switches, they don't take the data of VLAN 20, 30, 40 and 1007, only take data for 1 and 20 because 20, 30 and 40 and 1007 is not available there, means no one is attached there. Maybe it's created there, I'm not saying it's not created, but none of the system is attached. So let me check again, show interface trunk. Look at only take 1 and 10 data. Before it was tomorrow, suppose you say no 20 is added there. Go to the trunk interface and type here switch port trunk allowed VLAN add. Keep in mind you have to add them and say VLAN 20. Before it was 10. Let me check again. Do show interface trunk. Do show interface trunk. Now 20 is also there. There was no 20. If you check that no, 10 is not more there, you can instead of add, you can say remove VLAN 10 and do show interface trunk. Now 10 is removed. But this is manual method. You have to care. If you forgot, the traffic will not go from this VLAN to this VLAN because it's not allowed on a trunk interface. But in other method is automatic method. This is pruning. This is switch has to care about. And we test the lab and everything. So this was VTP.